Hi. In this tutorial, I'm going to cover something that has been a recurring theme both in my design career and also all of human history. Our friend, the handle. I'm a big fan of using handles to demonstrate SolidWorks modeling techniques because, well, there's two main reasons. Firstly, they're intuitive. It's real easy to hold a prototyped handle in your hand and realize whether or not you got it right. It'll either be comfortable and fit your hand well, or it won't. Which brings me neatly to reason number two, is that they're kind of tricky. You're almost never going to get it right on the first try. I certainly never have, and all the handles I've ever made been perfect right out of the bat. There's always room for improvement. What that means for our process as designers is that we're anticipating having to change our model after we go through a round or two of prototyping. Tweaking a model based on feedback is half of our job as industrial designers, and we can save ourselves a lot of time and be more efficient if we set our model up in a way that's intended to be tweaked. As I've said before, what you dimension and what you define is what you get to control. So when you're picking things to dimension and define, it's really important that you are gaining control over the model in a meaningful way. Here, if I 3D printed this model, I would realize pretty quickly that, I got my finger spacing a little bit wrong. I'm going to bring those a little closer together. Also, my overall height is slightly larger than feels comfortable in my hand. Perhaps I have too much curvature on the back, and also our finger wells are a little too deep. Now, because I've set up the model in a way that makes it easy for me to change all of these parameters, making changes based on feedback from a prototype should be fairly straightforward. Now, they're not always going to rebuild in a happy way, as you've just seen here. There will be some explosions. It's sort of inevitable. I'm not going to pretend that doesn't happen to me, too. The important thing to take away, though, is that once we have a good modeling flow with reliable, robust master sketches and a good understanding procedurally of how we get from sketches to the end of the model, it's going to be pretty easy for us to control those sort of explosions and stay on target. As designers, we always want to be as efficient as possible. And that means that when we're setting up our sketches in SolidWorks, we need to be aware of what our workflow is. And because when it comes to handles and most ergonomic objects, our workflow is going to involve some back and forth, we want to make sure that we are putting the necessary time in beforehand in order to make our future anticipated changes faster and more efficient. Spending a little extra time at the outset can save us a lot of time on the back end. So let's get started with our master sketch. In this case, because the most complex information about this part is viewed from the right side, I'm going to put my master sketch on the right plane. My first master sketch, that is. Because the object that I'm sketching is symmetrical, I'm going to start with a construction line representing that axis of symmetry. That's really helpful for when I need to make things tangent, so that I get smooth transitions once my surfaces have been mirrored towards the end of the model. I'm going to draw these quick lines to give me a bounding box because it helps me keep things laid out. And now I'm going to add two horizontal lines at the bottom. These are going to help me lay out the arc chain, which will define my finger divots. With the arc tool, I will lay in some arcs whose endpoints lay mostly on this middle line. Now watch out as you're drawing arcs near the midpoints of things. I mean, it doesn't just go for arcs, points, ellipses, other lines. It's very easy to accidentally grab a midpoint relationship if you have your automatic relations turned on. So that can be really confusing if a sketch starts behaving the wrong way because you ended up putting in a midpoint relation that you weren't expecting. Personally, I've pulled my hair out over these sorts of things before, so when you're drawing your sketches, make sure you don't accidentally land one on the midpoint, unless you want that midpoint relation. Next, I'm going to add some tangent relations between my between my construction sketches and my arcs. I'll do the same up here for the finger divots. And now I can start to make this arc chain tangent to itself. This is nothing to be afraid of. Happens all the time when we're working with arcs. All we need to do is just bend things back around to where they're happy. There. We've got some pretty wonky looking finger divots. Next thing we need to do is dimension horizontally the width of this handle, because that's something we can change with the mouse. So with a smart dimension, I can dimension the width of this, what is really half of the handle, or by selecting a point and the midpoint, I could dimension with a double dimension the overall final width of the handle. But in this case, all three of these methods are equally valid. I'm going to dimension incrementally one cycle of this sort of sinusoid, which represents the distance between fingers. Now, with a vertical dimension, I'm able to dimension the height of this line, which represents, in a linear way, the depth of my finger divot. With a radius dimension, I'm able to add a dimension here which lets me control directly sort of the severity or the sharpness of the transition between one divot and the next. Now, as is almost always the case with SolidWorks, there's multiple ways of defining things. I don't necessarily have to have a linear dimension here. I could also use a radius dimension for these arcs, controlling the depth of the finger divots. The reason that I don't like that is because, at least for this example, there's nothing very intuitive about a radius dimension here. There's this weird nonlinear response as you get closer to the width of your arc in your radius. It's going to rapidly start growing until it can't model anymore and then breaks. So I find that in this case, while there is an appropriate use for radiuses or radii, I would prefer to use a linear dimension because as I do a 3D print or make a prototype myself, it's going to be pretty easy for me to just look at it and feel it in my hand and say, I wish these were a little deeper. Let's make them a little deeper. Or let's make them 1.5 millimeters shallower. Pretty easy to directly control that. So I've dimensioned it in a way which gives me control over something that I want in a way that I can easily understand. Next, I'm going to use some arcs to sketch the backbone. That's not an arc. I'm going to use some actual arcs to sketch the backbone of my handle. And I find when sketching very shallow arcs, I want this arc to be concave. When sketching very shallow arcs, it's easy to accidentally pop one in there going the other way. That's a real problem because SolidWorks never wants to flip the center point of an arc from one point to another. You can change your radii, but you can't flip a circle basically inside out. So in this case where I want this really shallow concave curvature, because I know I can easily change it later, I'm just going to draw it with an exaggerated curvature, guaranteeing that I lay it in the correct orientation. Something else that matters to me is that these lines are tangent to one another, so there we go. Arcs, sorry. Something else that matters to me is that I have a smooth transition when I go to mirror this object. Now, if I have anything other than a tangent condition at the axis of symmetry, I'm going to end up with an unintentional crease. So I'm going to make this tangent so we get a nice smooth mirrored transition. Now, with a horizontal line, I will add a dimension which represents the drop-off from the highest point of the handle to the lowest point of the handle. Now, I could select this arc and this horizontal line and make them tangent to one another. Now, that would give me a nice consistent relationship over here, something that would not change as I update other parts of the sketch, but I actually want more control in that. So instead of making that tangent to the horizontal, I'm going to make it tangent, it's wiggling around on me, I'm going to make it tangent to another line which I draw right now. That line is not horizontal, it's just a random angle. So by changing the angle of this line, I'm able to change, as you can see, the curvature towards the end of my handle there. With an angular dimension, now I can have some direct control over that curve. I will make these two lines, so these two arcs have an equal radius of curvature, and now the only two inputs that I need to control these arcs that form the backbone are this angular dimension and this drop-off height. So again, just like my lines down here, this is a visually intuitive way of controlling the many different factors that are required to define arcs. I'm happy with this sketch for now, so I will complete it. Next, I'm going to have to add some information about the depth of my handle, and I'm going to do that at two places. For starters, we'll start in the middle because we already have a front plane which lies right where we need to draw this little rib profile that gives us information about the thickness of our handle. There we go. I've just had to fix a quick graphical glitch about the display of my front plane there, so sorry about the interruption. So now that I'm sketching on the front plane, this is one of those conditions where it's really important to have consistent model geometry. The height of our model at this center point is already defined in the right plane. That's sort of the length of this line right here. That's the height of our model from top to bottom. Now that we're working in the front plane, to draw a different view of this model, it's important that our two views of the same part correspond with one another. The easiest way to ensure that is not by adding the same dimension in this sketch as in the other sketch, but rather by simply converting this line. This will update as we change the line in the right master sketch, and in doing so, ensure that our model is always consistent. If I added a linear dimension for this line, if I had sketched it from scratch and added a linear dimension, then I would need to update that dimension in two places if I ever wanted to change the height of the model. So now I'm just adding two arcs and a vertical line segment in between them. I'll make them tangent to the horizontal because, again, I want my smooth transitions. And now I'll add a linear dimension between this point and my center line to give me the overall width of my handle in that middle section. This is a pretty simple sketch. We need one more simple sketch to define this sort of end cap shape over here, but we don't really have a plane on which we can do that. So using the front plane as a reference and this endpoint in our right master sketch, we can use reference geometry sketch plane, or reference geometry plane, sorry, to create a new plane which whose position is defined by the overall width of this handle. Now on plane 1, I'm able to repeat the process that I did in my right master plane. I'm sorry, my front master sketch that we just drew here. Getting a little confused, my bad. And I will add some geometry to this sketch, which again references my right master sketch. Now I've added two horizontal lines which touch the periphery of our object as it intersects this plane. And I will again draw some profile geometry for this sketch. Oops. Making arcs tangent to lines. There we go. So now we have two ribs which define the sort of start and end conditions, or the extremity and central conditions for our handle. So we'll rename sketch 1 Groovy. Now that we have our master sketches laid in, we can clearly imagine the surface that goes between them. And it would be possible to create surface geometry from the sketches we have here. Instead of following the normal route of making baby sketches and then creating surface geometry between them, I'm going to go one extra step and create some extruded surfaces from these baby sketches. So here's my converted sketch, and now I will extrude a surface. Let's go 5 millimeters. Distance doesn't matter, but the direction does. I'll make sure that all my surfaces are facing away from the direction in which I intend to eventually create my boundary surface. I'll hide my planes and sketches, and now I can see I've gone one extra step, and instead of just converting sketches, I've created surface geometry from them. This is going to be important in a minute. For now, I will create a boundary surface using my selection manager because I have multiple selections to make for both the top and bottom. Indeed, all 4 edges of this will require the selection manager tool. I'm just going to work my way through this, selecting the edges which define my shape. There we go. Lastly, I'll add tangency to the faces where I want it. That's any face where it's going to be mirrored. Remember, tangency only works in surfacing if you have your entire model set up to be tangent. And we were very careful in our master sketch to make sure that we have a tangent condition with a horizontal here and here. But if you recall, when we set up this arc, we told it to be tangent to a line which is not horizontal, because I wanted that little bit of fine-grained control over the curvature here, which means that Solidworks will not be able to give us a tangent relation to this surface. That's totally fine. It's the way that I ended up making this model, and it's a design decision that I made. So just note that the reason I have not selected tangency to face for open group 3, which defines this curve here, is that that was never a goal of mine. Now that we've got our boundary surface, yay, we can use our delete/keep bodies tool to remove these guide bodies now that we're done with them. This is far superior to hiding. It looks like we got a good curvature result down on the bottom where our fingers go, but we do have this unfortunate propagation of that curvature all the way through the model, which results in some sort of unpleasant wiggliness up near the top. Now, maybe you could get away with this, maybe not. That's not really what I'm interested in. I'm interested in making sure that my design intent is carried all the way through the end of the product. So I'm going to view this, comfortable or not, as a failure, or at least as an area where I need to improve. Something to take note of, and this is relevant to a lot of different surfacing operations, is that I have a waistline here, which is wiggly. And you can see that clearly in the reflection. It's generated from these two vertical lines where I have my arcs meeting in my side profiles. But if this were a single point, then our waistline would just be a single line, but it would also follow this wiggling curvature. What I want to do is manually take control of that waistline rather than let it be sort of incidentally generated through the boundary surface. I want to draw it in 3 dimensions, so I'm going to use a projected curve. In order to do this, I'll roll back before I created any surface geometry at all and simply had my master sketches. On my right plane, I will create a sketch that borrows some geometry from my right master sketch, namely the overall height. There we go. I'll hide that sketch, and now I have 2 lines which represent the height of my model. I'll make them into construction geometry, and I'll use 2 horizontal lines from the midpoints of these lines, extending horizontally outwards, to guide the endpoints of a spline as well as its tangency. Not you. Tangent. Horizontal line, spline, tangent. By adding linear magnitude scalars to the handle dimensions here, I'm able to control the curvature of that arc, or sorry, the curvature of that spline. So I'm going to name this waist X, because it is a sketch of the waist and it is on the plane perpendicular to the X axis. That's just to help me keep organized. Now there's one important step before I draw the other part of this projected curve. We know when we have a projected curve, we need at least, actually, we need exactly 2 sketches in different planes in order to guide that 3D geometry. Now that I have this line laid in, I'm going to roll past my surfaces. I'm going to create a new sketch, and I'm going to convert this spline and then draw some horizontal lines on the end of it. The length of these lines is not particularly important beyond the fact that it needs to extend further than my extruded surfaces here. Provided that the lines extend beyond my extruded surface geometry here, I'll be able to use the Curves Split Line tool with the projection mode selected. Current sketch will be selected by default because we're doing this from within a sketch. And then by selecting these 2 faces, this tool will project this line and then divide this face where it would intersect. This is super duper important because, as you saw when we were using our selection manager to select edges for a boundary tool, this used to be one line. Now it's been divided into 2 edges. There's an edge here and an edge here, where before our split line tool, we had only one edge. And if I want to divide my boundary surface into two faces, first from the upper portion to my curve, which I'm going to create in a moment, and then from my curve to the bottom portion, being able to have this side guide curve, this side guide geometry, end exactly where my boundary surface ends is really helpful. So now we have our guide geometry split where our center waistline intersects it, and all we need is the vertical component of our waistline. So on the top plane, we'll hide my sketches, and I will create a spline. I'm just going to sketch it in free space, and I will take the endpoints of this spline and make them coincident to the points that were created by the split that we did just a moment ago. When viewed from the top, perpendicular to the sketch plane, I can add a vertical line and make it tangent to the spline so that I have a smooth curvature when I mirror that spline. And I think I might even be happy with this curvature. I don't feel the need to push and pull this handle down here. I'm just going to leave it as it is. Incidentally, a spline that's defined on only one end is a parabola. So we have a parabolic curve when viewed from the top. From here, I can select my two sketches, my projected curve, with the sketch on sketch option selected, and then I can see how my two sketches have come together to form a waistline, as well as, along the way, split my guide curvature in a way that is going to allow me to create this surface with not just one boundary surface, but two. So here's our boundary surface, and as expected, it's broken. I could just delete it, but instead I'm going to edit it and clear my selections. No real reason to do this. It's just I like to not delete things. I like to edit them to make them work. So I'm going to use my selection manager to select the top. Then I will just select the bottom curve, which represents our waistline. I'll use my selection manager again to select this first curve, and now there you can see the importance of splitting this surface. It allows me to directly select only the portion of it that I need. Come back. Just as before, I will edit my tangency. There's half of our surface, and we can see it's perfectly smooth as we wanted our handle to be in the first place. Now with one more boundary surface, I'm going to hide my curve, that's important, and I'll use my boundary surface again to select the bottom edge. And there we have what was formerly made in a single boundary surface. Now we have two boundary surfaces we can knit together, see that they're perfectly tangent, and now my beautiful curvature on the bottom continues only up until this waistline which I sketched, and my top curvature is nice and smooth as I originally intended. The next step is to add a planar surface, which encloses this end cap of the handle. In doing that, when I eventually mirror all four quadrants, I'll end up with a fully enclosed volume, which I can then easily convert into a solid piece of geometry. Because the last thing I did in my feature tree was create this surface knit to connect the upper and lower boundary surfaces together, and I know I'm going to add a new feature which I want to be knitted in, I'm going to roll back before the surface knit. That way I can create my new planar surface and then roll forwards and include it in that original surface knit without having to add any additional or superfluous surface knits. Just keeps my feature tree a little bit more organized. What I've done here is to borrow, by converting, the master end cap lines. So I took that master sketch and I'm going to add a vertical line to it. Now I have a closed sketch that I can use to create a planar surface, as you can see here. And by rolling past surface knit 1 and then editing it, I'm able to include that new planar surface in the surface knit. So we still just have one surface knit, and now it's connecting 3 features instead of 2. Next step is to, in our Features tab, use our Mirror tool. Mind you, we are mirroring bodies, not features or faces. I'll mirror about the front plane. Next, I'll mirror about the right plane. And there we go. Here's 1, 2, 3, 4 surface bodies, which I can, with a surface knit, connect to one another. And by selecting the Create Solid option, without checking off gap control, I'm able to convert that fully bounded surface, I'm able to convert the surface that fully bound this volume into a solid volume. There you have it, a solid handle. If you're following along, I suggest you save your work now, because as we discussed at the beginning of the tutorial, the whole point from making this model this way was that we can push and pull and tweak the master sketch, master sketches, we have 3 of them, to change the proportions and the size of this handle. You should be able to make most changes to the numerical values we've assigned to the smart dimensions that control this handle as it currently is modeled. If you want to make more substantive changes, changes that involve replacing geometry, here you can see I have an arc, a vertical line, and another arc that form the profile of the side of this handle. I can change some information about those. I could maybe put that vertical line on an angle and make a little bit of a change that way. Let's do that right now. No longer vertical, but instead at an angle. Let's make it 10 degrees. Now it looks like my model has rebuilt okay. That won't always be the case. When I'm making changes to sketches like that, I may do something that disrupts the flow of the model. That's not a deal breaker. It's not the end of the world. We can always go back and edit it. As you can see here, this handle is built on basically the same bones as the handle that we were just looking at a moment ago, but you can see I've changed some other things, like the bottom portion of my master sketch is no longer horizontal. I have it at an angle so that the bottom of my handle curves upwards. Also, the side profile, the X master sketch, is no longer comprised of 2 arcs and 1 vertical line. I now have 2 splines. By fully dimensioning the splines, I'm able to achieve a little bit more control over the exact proportions of the handle, and able to control the curvature more than I am with just a single arc, or a pair of arcs. However, making that change required me to change some other things about the way the handle is defined. I basically just had to reselect some edges on my boundary surface, change my split and my side curve a little bit. But these are the sorts of things that hopefully you'll be able to work out on your own. That's sort of the meat and potatoes of learning SolidWorks, is, especially surfacing in SolidWorks, is once you've got your master sketch bones down, how then, by understanding your model flow, are you able to make changes to your model after you've gotten to what we could call a stopping point? Being able to start with simple master sketches and a simple model flow and then go back and tweak it reliably and repeatably is sort of the golden standard of modeling complicated shapes in SolidWorks. I hope this has been helpful. If you have any questions, feel free to leave them in the comments. Happy modeling!